Hello, this is Mr. Agbamu Idonogrene. Okay, let's continue with what we have been doing in rate of change. This is another example I have for you. So if you check the previous video I did, we explained the fundamental of a rate of change, all about what it means and how you can go about it. So now let's go to another example. So looking at this question, let's see what the question is talking about. The question started with the area of a circle is increasing at the rate of, you see, they just give you the rates. So what we need to do here is the area of this circle is increasing at the rate of 4 centimeters square per second. That means the area is changing with respect to time. Since they didn't tell us that changing with respect to time, so you must take it with respect to time. That's what this topic is talking about, rate of change. When the width is not given, the width change is not given, so take time. So what I need to do first in this place is I'll just say the dt is going to be equal to this value that is given, which is 4 centimeters square per seconds raised to power minus 1. That is it. So that is that. So this is what is given in the question. The dt, the area of a circle, is increasing. So it is the area that is changing. See, it's changing by increasing at the rate of 4 centimeter square. You can say centimeter square is the unit for area, which is the numerator. The area divided by time, which is seconds, that is t. So this is what is given in the question. Then let's move on. The question now says find the rate of change of the circumference. You see, circumference when the radius is 6 cm. So this time around, it is the change of circumference the question wants us to calculate. And when we take C, let's take C as our circumference. That means the C, the T. Remember the question says find the rate of change of the circumference. Since they did not give you with respect to anything, that means the respect is going to be with respect to time. So, and we don't know that. That is the C, the T. So this is what we are calculating. We don't know the result yet. So just put question mark. Then how are we going to get this result? If you remember our previous example, he asked us to find the rate of change of the area. So we use area of a circle. We differentiated area of a circle. Now what they want us to find the rate of change in this question is circumference of a circle. So what you need to put down here is the formula for circumference of a circle, then differentiate it. Then you now use your chain rule, and that is all. Just wanted to know that this topic is not a difficult topic. Number one, know what is given, know the rate of what is given, then know the rate of what you are calculating. Then with your chain rule, you can do the analysis so that you can get the correct information to solve it. So now, what is the circumference of a circle? So C, if I take C as my circumference of circle, C will be equal to what? That is 2 pi r. So this is the formula for circumference of a circle. If I differentiate this circumference of a circle now, which is the C, the r. No, we differentiate circumference of a circle with respect to r. So the C, the r is going to be equal to 2 pi. Remember our basic rule of differentiation. So the C, the r is going to be 2r. Get it? The power of r is 1, which will multiply 2 pi. Then power of r is 1. 1 minus 1 is 0. R raised to power 0 is 1. So this is the differentiation of 2 pi r. Since 2 pi is a constant, so that is the result. Now we already know the C, the r, but the question tells us to calculate the C, the T, not the C, the r. So how do we get the C, the r? Let's see what we are going to do to get it. Okay, let's see this, the A, the T. I think it can help us in our analysis here. Let's see how it can help us. Or let's see, okay, let's put area. Since they gave us the rate of change of area, let's bring out area of a circle. So we all know that area of a circle A is equals to pi r square. So this is area of a circle. pi r square. So let's differentiate area of a circle, because we can see dA dt, differentiation of area of a circle with respect to time, is given. You see? So let's find the change of area with radius. How does area change with radius? Since we know how circumference changes with radius, but area is what is given. So let's also differentiate this area. So we have dA dt, sorry, dr. Differentiation of this area of a circle is going to give us what now? It's going to give us 2 pi r. So that is what to give us, which is this. Okay. Alright, now that we have this, so let's see how we can move on now. We need to get this value. This is what the question wants us to calculate, dc dt. So let me come here and do it. So also using of chain rule. So don't forget, it's chain rule we are using always. Using your chain rule. So how are we going to use chain rule? Just that if we do dA dt, let's do it like this. dA dt, which is this value now. If you divide it, let me use this division symbol. If you divide it by this value we are looking for now, which is dc dt, you will see that your result is going to be equals to dA dr, then divided by, let me use this division symbol, divided by this value we have here, which is dc dr. So that is it. You get the principle here, because I'm not going to solve it out, but let me just solve it out so that you see what we are talking about. You know, if I solve this place out, you will discover that dt will come up here, the dt will come up, dc will come down, so dt is going to cancel out dt, so we are going to have dA divided by dc. If I come here, the r will come up, the c will come down, here will now be times, you understand? So the r cancel the r, so I'm going to have dA divided by dc. So you see that both of them, they are equal. dA divided by dc is equal to dA divided by dc. So this is the chain rule we are going to use to get our result for this question. You can see it's a little bit different from the first example we did, but all I want you to learn in this rate of change is try and check your division. Make sure the division you are using must give you the second side of the division, so that what you are looking for will come out clearly. That's what the chain rule is talking about. You see what I tried to do here? dA dt, which is given, divided by dc dt, which we are calculating in the question, which is find the rate of change of the circumference, which is this, and I made it equals to the change in area with respect to radius, which is dA dr, divided by dc dr. If you do the calculation, you see that both of them are equal. So if both of them are equal, all I need to do now is substitute the values I have. So dA dt, I have 4 according to the question, which is the area of a circle is changing, it's increasing at the rate of 4. You can see it. So I have 4 divided by, so let me use this division also, 4 divided by dc dt, which is what I'm calculating now, dc dt, then it will be equals to what? dA dr. dA dr is, we did the differentiation, which is 2 pi r, that is 2 pi r, then divided by, let me use our division symbol, so divided by dc dr, and you can see dc dr, which is circumference of a circle, which is 2 pi r. We got 2 pi when we differentiated it, divided by 2 pi. So that is it. Then at this stage, do your basic mathematics. 2 we cancel 2, pi we cancel pi. Then when you cross multiply, you can see the work is not difficult again. So I'm having 4 divided by, let me just go one step, 4 divided by dc dt, which is equals to r. You can see it's 2 pi, I've already cancelled 2 pi, leaving r. Then what are we going to do next? So you know this is 4 divided by this, so let's cross multiply. If I cross multiply with this, I'm going to get 4 is equals to r multiplied by dc dt. So r times dc dt. Then if you divide both sides by r, understand, divide both sides by r, our final result is now going to be, okay, let me not even move down, let me just do it here. When you divide both sides by r, the final result will be dc dt will now be equals to 4 divided by r, 4 divided by r. So you can see we have proved a formula for dc dt. So with this we can get our final result. So dc dt is now going to be equals to 4 divided by r, is the question is given as 6, so divided by 6. So that is all. Then we can take it to the lowest form. 2 can go into 4 and 3. So final answer dc dt is now going to be equals to 2 divided by 3. So this is your answer. And what is the unit change in circumference? Circumference is also unit of length, that is centimeter divided by time, centimeter per centimeter per seconds raised to power 1. Sorry. So this is the answer, 2/3 centimeter per seconds. So that is all with this question. So I hope you understand this particular one. You can see it's not a difficult question. It's only this place. Most students always see this place as confusing. But all you need to do is make sure you use the right information. This divided by this is equals to this divided by this. Then when you check, make sure you always check before you move on. Make sure when you check, when you cancel out, the values you get in left hand side, the a divided by dc must be equals to the a divided by dc. If they are not equal, then check it well. They must get something that will be equal so that you can be able to solve it. So that is example 2 in our example. Let's look at one more example, then we'll have some practice question for you and we'll move on. This example 3, this one I picked it from this examination, JAM Mathematics. So if you go to your JAM past question, you will see this there. So I picked this from JAM year 2000 JAM, and it's type A I have with me. So the number is number 34. So this time around they are talking about the volume of a hemisphere. See, if the volume of a hemisphere is increasing at a steady rate of 18 pi, you see this is volume. You can see the unit meter cube per second. So how is the volume of this hemisphere changing with respect to time? And it's changing at the rate of 18 pi meter cube per second. Now let's bring out the major information. So the information here is dv dt. This is the first information that is given, that change in volume of this hemisphere, which is dv divided by the time with respect to time, is given as 18 pi. Then the unit is meter raised to power 3 meter cube per second. Sorry, meter cube per second. Okay, so this is the first information given. Then as usual, what are we calculating? Then I say, at what rate is each radius changing? So we are looking for change in radius. So what this question wants us to calculate is change in radius divided by change in time. So this is what is not known. So that is question mark. I think by now you should understand what we are doing in this rate of change. You will notice that I will always bring out what is given, then I'll put down what is not, what is to be found. So this is what to be found, this is what is given. Now we have them side by side. You know the secret now is I need to differentiate something such that when I divide, it must be equals to this value we have here now, the r dt that we are going to calculate. Now what is given in the question? We have volume of a hemisphere. Let's bring out the formula for volume of a hemisphere. So volume of a hemisphere V is equals, remember this is hemisphere, not a sphere. So hemisphere is 4/3. That's the volume of a hemisphere. The constant is 4/3. Volume of a sphere 4/3. But hemisphere is going to be 2 divided by 3 pi r raised to power 3. So this is the volume of a hemisphere. Take note of that. This volume of a hemisphere. So let's differentiate this volume of this hemisphere. The V, the R. Let's differentiate the volume with respect to the radius. So the basic rules of differentiation, 2/3 pi is a constant. So 3 is going to multiply the constant. So 3 times 2 is 6. 6 divided by 3 we have 2. So this is 2 pi. Then subtract 1 from this power, r raised to power 3. When you subtract 1 from power 3, you're having raised to power 2. Sorry, which is r raised to power 2. So this is the differentiation of the volume of the hemisphere. So let's check again. Differentiation of volume of hemisphere, which is this. When you differentiate it, the VdR is going to give us 3 times 2, yes, which is 2, pi r minus 1, which is this. So we are correct. So now what next? Let's see what next. Okay, now I said the question now said, at what rate is its radius changing with it when it's 6 meters? Okay, let's see now. So no more information is given for us to try and see. So let's go straight now. Let's see how chain rule can help us now. If I multiply, let me see, if I multiply the V dt with dr dt, this times this, will it give us something like this? We just need to check and see. So let's use our chain rule and check. If I use using the chain rule, let's see. So let me see now. So dv dt, let me start with dv dt. So if let me use this now, dv. This is what we do. You must check something that should be able to divide so that you will not make mistake. If it's not giving me what I want, I will change it. So if I use this now, dv dt, if I multiply it with dr dt, will it give me what I want? Let me see. Let me see if it will be equals to this. Let me times and see first. Dr dt. Let's see. See, it's giving us dv dr. You can see it times dr dt. So dr can cancel dr, so we are correct. Dv dt will be equals to dv dt. So since this is correct, that means we can move on. So what is dv dt? Dv dt is giving us 18 pi. So you put your 18 pi. We can put the value of pi, but let me just put the pi first. 18 pi will be equals to dv dr, which is the differentiation. We got 2 pi r square, which is 2 pi r square, then multiply by dr dt, and that is what the question says we should calculate. That is, at what rate is its radius changing? So how is radius changing with time? At what rate is its radius changing? So dr is the radius. How is radius changing with time? That is dr dt. So this is what we are calculating. This is what the question says we should find, which is this. So that is all. Then what next? Divide both sides by pi. When you divide both sides by pi now, so pi, we cancel pi, so pi is out. Then if you divide both sides by 2, 2 divided by 18, we have 9. So that is also, let me just divide both sides by 2 pi r squared without wasting time. So I have dr dt will be equals to 18 pi divided by 2 pi r squared. So when you divide both sides by 2 pi r squared to come under 18 pi, that is it. which is equal to dr dt. So let's cancel out now. This one is going to give us dr dt will now be equals to, this is 9, 18 divided by 2 is 9, pi we divide pi, leaving divided by r squared. So that is all. So with this, our work is over. Let me put our final answer here. So we have the r dt. The r dt will now be equals to what now? 9 divided by, the radius is given as 6. You can see it's when it is 6. At what rate is its radius changing when it is 6? So when radius is 6 and 6 raised to power 2, you know what is that? That is 36. So final answer, the r dt will now be equals to 9 over 36. So what is common? I think 9 can go also. Or let's leave our answer in decimal, because in the objective question the answer is in decimal. So let's just leave our answer in decimal, which is 9 divided by 36 equals 0.25. That is 0.25. And the unit is what now? This is radius, which is meter. Remember, the question comes as meter. Radius is meter divided by time. So meter per second. Meter per second. So that is it. So that is all with the question, and this is all I have for us in rate of change. Think there's no problem with rate of change. I've given you the secret. Just know what you are giving. According to this question, if the volume of hemisphere is increasing at this steady rate, so the volume of the hemisphere is given at the rate of this, which is divided by time, 18 pi. Then the answer we should find the rate at which radius is changing, which is dr dt. You can see it there. Then what next? You now need to get the volume of the quantity that is given, which is the volume of the hemisphere is what is given. So volume of hemisphere is 2 over 3. Then you need to differentiate it with respect to r, and that is what I've done. I've differentiated it with respect to r, so I got this. Then what next? You need to apply your chain rule, the correct chain rule, to give you what you need to find. And when I use dv dt equals to dv dr times the r dt, you can see it gave me exactly what I want. When the r cancel the r, is equals to dv dt. You can see it here. So that is, everything is open. Then do your substitution of values given, solve down, you will get your answer as 0.25. So that is all I have for you now. So there's no problem with this. So I hope you understand all we did today. Just want you to go through the videos very well, and you see that there's no problem with it. Then when you are through with that, then you can check these 2 questions I have here. Then there's no problem with this also. Just go through the videos very well. This first question is on volume of a sphere, so you know what to do. After bringing out what is given, differentiate volume of a sphere, then you do your substitution with chain rule. Then this time around they give you angle of a sector. This is the angle 75 degrees, that is the theta. Then if the radius of a circle is increasing at this rate, so this one now, the rate that is given is dr dt is given. Then I say find the rate of increase of the area of the area when the radius. So this time around, all they wanted to do here is get your area of a sector. So it's area of a sector that this question is focusing on, because I said the angle of a sector of the circle is this. Then the next told you that the radius is increasing at this rate. So you get your area of a sector, differentiate it, do the necessary chain rule substitution, you will get your result, and that is all for rate of change. So I hope you enjoy this video. So do have a nice time. Take care.